Greetings again. I said in the last video that that I would move on from there, but that has not turned out to be true. I feel, one more video to go in this. So here I am again with an update on the metaphysics of relations. What I want to say concerns the ideas in entanglement, which have not been, I think, properly brought into this discussion, and this is my attempt to do so. Most discussions of entanglement really don't involve more than two particles, particularly by philosophers. I want to discuss three particles, and I want to discuss a particular property that what is called multipartite entanglement relations can have. So the first thing I want to do is talk about three parties, A, B, and C, and three particles, A, B, and C, and what happens in the relations between them in the possible states of entanglement that they can have. Now, to introduce you to this, I want to take it to the level of human beings and their relations. Suppose we have two people, call them Alice and Bob. Now, suppose that they're in love, and suppose that they have what we will call the perfect love. The perfect love is not just being in love, but in being in love to its maximal extent. Now, if Alice and Bob are in love to the maximal extent, and we'll think of this as on a range, so we'll actually put the minimal amount of love that they could have, none at all, as 0, and we'll put the maximum amount of love that they could have as 1. Now, in this case, suppose that they do have the perfect love. Now, this is not that they are the perfect lovers. That doesn't mean that at all. They can be, perfectly ordinary people, but they happen to have and to share the perfect love. What that means, essentially, is that suppose that there is a third person, call him Colin. Then Colin can't have any love, share any love with, say, Alice. Alice's love is going all to Bob, and there's none left over for Colin. So we would think of that as a form of monogamy. The perfect love is a monogamous love, and it precludes the love of some extraneous third person, which we're going to call Colin. So, love, the perfect love, this measure 1 love, that's what we're going to call it. It's perfect, so it has measure 1, which means it's the maximum it can have. This measure 1 love that Alice and Bob have is unshareable because there's none left over to share with any third party. That's our Colin. One should sort of pronounce it in a sort of way that suggests that Colin is dastardly and not a decent fellow. Colin. There's none left over for Colin. Colin can't get any love from Alice because it's all been given over. So, this is a kind of monogamy, a monogamous relationship. And it's not implausible. So, I'm not saying it's likely to be encountered much. I don't think it is. But this monogamous love that Alice and Bob can share precludes any kind of side love between Alice and Colin. Now, This relation is in fact a mirror of the kind of relationships that particles can have to one another when they're entangled. So suppose that we have two particles, and we're going to call them A and B, for Alice and Bob, A and B, and that they are completely entangled, perfectly entangled, if you like. They have entanglement to the max, entanglement 1, if you like. What that means is that any particle C, for Colin, is not able to be entangled with the Alice-Bob pair, or with Alice by herself. So the Alice-Bob pair cannot be sort of invaded by the third party Colin. So what they have is called entanglement monogamy, these three particles. And what it means is that there is a quantity of entanglement between the particles A and B that are the resource here, and that there's no resource left over for C. So A and B share the maximum amount of entanglement, and that means that there's no entanglement left over for C. What that comes to is that this was the view and the proposal of William Wouters. William Wouters suggested this, and the idea comes from him. Wouters' idea is that entanglement is a resource, and it's a finite resource between particles that can be exploited. And once it's at a maximum, then it can't be shared with that third party, so it's called entanglement monogamy. Entanglement monogamy. Basically on the very nice, beautiful metaphor of the perfect love between Alice and Bob, we have the perfect entanglement between A and B as particles. Now, what we have here is a serious refinement of the idea of entanglement. Philosophers discuss this almost as, well, not almost, but actually as though there is just a sort of an entanglement, a yes or no matter. You're either entangled with another particle or you're not. That's it. But Wouters is making a serious refinement on that idea by postulating the existence of an amount, a resource. So what that means is that entanglement as a relation, as a correlation, is an intensive relation. It has a quantity attached to it. It's an intensive relation. So the perfect love, or love in general, is an intensive relation. You can have two people with no love, that's 0. Or with a little bit of love, that's something between 0 and 1. Or the perfect love, that would be one itself. So modeled on that intensive relation of love, you can have this intensive relation of entanglement. Now, most relations are not intensive. For example, if you have a brother, it makes no sense to talk about, well, he's so much more a brother than any other brother that I can think of. He's maximum brother. He's got more brotherness in him than, or in the relation between than any other brother could have. I'm not sure that makes any sense. But, some relations do seem intensive. I don't believe at all in luck. I don't believe that there is such a thing as luck, and I don't believe it can be have a quantity attached to it. But the people who do believe in luck do think of it as an intensive relation. They might think, well, when I'm at the roulette table, I have this amount of luck, but by God, when I'm playing poker, I seem to have a great deal of luck. So, or maybe, possibly, the perfect luck. There's something like this in Dostoevsky's story, The Gambler. That story suggests that Dostoevsky might have thought of luck as an intensive relation that one could have to particular environments, particular games, etc. He was a gambler, of course, so it makes sense for him to think that, and he was of course, a loser at gambling, and owed lots and lots of people money. The reason why he wrote his brilliant novels was because he was a gambler who owed money everywhere, and broke off a lot of friendships as a result. I'm not sure that there are too many other examples that I can easily think of. Brother doesn't work, wife doesn't work, love works, but intensive relations are a special class of relations. It's just that now it seems, thanks to Wouter's work, that entanglement may well be an intensive relation. And this is given the idea that if entanglement is an intensive relation, then we could have more of it. We could have a lot of it, or we could have less of it. If we have less of it between two particles A and B, then there's more of it to share with colon C. So we have that. Because it's a resource, we can also parallel it to electricity. It's like a quantity that we can use. So electricity is an intensive relation. For example, the current between 2 points A and B can be 0, or it can be a very great intensity indeed, as in lightning. So we can think of electricity also. It becomes a resource, and we can use it in various applications, in various ways. In a sense, it doesn't have a maximum that at least we know of. And so it becomes a very, very usable and extensive resource. So now, that's the idea. There aren't that many examples of this, but those will do. Now, this intensive relation provides an important modification to entanglement in quantum mechanics, and it suggests that what we have here is something that is very practically useful, but we haven't found exactly how we're going to use it yet. But the idea was to use it in quantum computing in some way. Whether that has eventuated, I'm not sufficiently knowledgeable to say, but that was certainly one of the ideas that was behind Wouter's claims. Okay. Now, this goes to some extent to modifying our idea about holism in quantum mechanics and what holism actually means. What I said in a previous lecture is that holism, we seem to think of it as an all or nothing affair, and I think that's because most people get their idea of holism from Hegel or someone like that, or someone who's Hegelian and who has ideas borrowed from Hegel. And so we get the idea that holism comes as an all or nothing matter as well. Everything is entangled with everything else, or everything is connected with everything else. That seems an all or nothing matter. But the holism of quantum mechanics is not quite that. It's not an all or nothing matter. For example, if A and B share the perfect amount of entanglement, maximum amount of entanglement, then it can't be shared with C, colon. That suggests that holism is not an all or nothing matter at all in quantum mechanics, that colon, for example, may be separated from and separable from Alice and Bob, A and B. So we have something very different. And we don't really understand what's going on with holism unless we begin to separate out the various ways that we can have holism. It's not all or nothing, it seems. Hegel was wrong. At least in entanglement, it gives us something else. Now, the final point I want to make is that entanglement, if it in the way that it contributes to holism, is very, very tricky and unique. For example, what happens if you go to 4 particles? Something like an orgy. What happens in 4 particles? Well, that's an interesting question. And I think the answer was that the measure that was being used in the 3-particle case doesn't quite work when you carry it over to a 4-particle case. And I'm not sure that there is any resolution to this problem just yet. I'm not sure that they know exactly how to measure the monogamy in 4 particles. What would that look like? There are many ways that 4 particles be entangled. Don't quote me on this, but my memory is that there are 9 ways for 4 particles to be entangled. That's a dim memory that I have. But given that, how are they going to be sort of paired up with one another, and what is going to be the 3 particles out of the 4 entangled with leaving out the 4th, and then all the 4 particles entangled together? What is going on there, and how does that work in terms of sharing out the entanglement in all of these cases, these kinds of cases with the 4 particles? Well, it doesn't seem to work in the way that it did with 3 particles, and it's not clear to me, at least, they completely understand how it's going to work in 4 particles, and therefore I don't think they quite understand how it's going to work in 5 or 6 particles either. The general principle of monogamy may work, but how the measure works in those cases seems to be unclear. So what we're going to get is sort of, until this is worked out, we're going to get rather an awkward discussion of holism, where we believe that holism can be whole or partial, but we don't have a clear guide for it. So we have, as it were, one form of holism, the Hegelian form, everything is connected to everything else, and then the quantum mechanical form. Sometimes things are connected together perfectly, sometimes they're connected imperfectly, and that allows some of those parties to be connected to other 3rd parties and 4th parties and 5th parties and 6th parties, etc. That will likely be the case. All of this, I want to point this out because it's the philosophical consequence. All of this has devastating consequences for the idea, which every philosophy student encounters, of possible worlds and possible world semantics for modal logic, which since the 1970s, 80s, has become almost an obsession with some philosophers who think that modal logic can answer questions which I'm going to suggest it can't and doesn't answer. And it doesn't answer them because modal logic is based on the idea in its semantics that one can always take 2 things and one can vary them independently. One has one person, for example, and we can vary that one person's, call her Alice again, we can vary Alice's properties. She could be wearing a blue jumper on one occasion, and in another possible world she could be wearing a green jumper. We can have 2 people, they can be related to one another. In one world they're married, in another world they're not married. In one world they don't know one another, etc., etc., etc. The variation of these independent things is really the basis for possible world semantics. And we think that that's always going to carry on together. But the situation with holism suggests that it's not correct at all. If Hegel were right, if everything were connected to everything else, it's not at all clear that there is any world other than the actual world. What's another possible world? Well, how would that vary? How would you have anything other than Alice having the red jumper that she's got on right now? How would that matter? How would that make itself manifest? You can only have that red jumper on because of all of the other things in the universe that are fixed in the way that they're fixed. It would be impossible for there to be a variation in Alice because of the way the universe is. So there's one possible world, the actual world, or the possible worlds have to vary somehow wholly. Not in the way of, as it were, every individual, but altogether, as a whole, as a mass, as it were. And that would not be what possible world semantics would want. It wants variations from the actual world. It pretends that the actual world is filled with individuals with properties, and that those individuals and properties can vary. The individuals can vary. Alice can be in one world, but not in another world. And Alice in this world can have a red jumper on, but in another world she would have a green jumper on or a blue jumper on. In that way of thinking, that makes sense. But what I'm suggesting is that in quantum mechanics, in the world of physics, in the world that we actually live in, it doesn't make sense, and it may not make sense. We have only a partial, and we have no computational access to what are the possibilities. One possibility in the actual world might be, well, Alice and Bob have the perfect love, so there's no room for Colin. Another possibility would be, well, they don't have the perfect love, and there is room for Colin. That's a variation. But until we know what as it were, the numbers are in these cases, we can't tell what the other possible worlds are. And we don't know whether what the world consists of at the quantum level would be things, objects, and their properties. Both of those may be in doubt together in quantum mechanics in a way that I haven't quite gone through, but in quantum mechanics, it's not the case that we have things with their properties. Instead, we have a much more complicated situation. We have several philosophers, going back to Bertrand Russell, Alfred North Whitehead, and Eddington, in Britain in the early years, who had taken this message on very quickly and had thought, and often said, and in fact Whitehead made a whole philosophy out of this, there really aren't objects with properties. That's not the right way to put our ontology. It was called process philosophy for him. So this idea of objects and with their properties is for him incorrect. And if that's right, and if he did embrace a kind of holism, if that's correct, then possible world semantics has nothing in the actual world to work on. So I want to suggest, and I'm saying this partly because when I taught philosophy, it was very clear that one of the great sticking points of this kind of metaphysics, which I was never an enthusiast for, was that there's something really that smells. That there's a rotten fish aspect of possible world semantics. It seems to be, not that students ever sort of saw this aspect, but it seems like a kind of theology, a sort of an excess of entities and an excess of worlds, an infinite number of worlds, for no obvious gain. And in fact, what I'm suggesting is that my students were right. Their instincts were right. It's too much. It's far too much. And we don't have any kind of epistemic access to all of that. And what I'm suggesting now is it's worse than that. What we know about in quantum mechanics is that that picture must be false. The possible world semantics is based on an ontology of things and their properties that are separate from one another. As Hume said, they seem all loose and separate. And because they're loose and separate, they can vary independently of one another. What I'm suggesting is that it's probably a fundamental feature of the universe that things cannot vary independently of one another, except probably in isolated cases where you do have something like a quantum separability. And in those cases, sure, you can vary Colin while you're doing nothing, as it were, to Alice and Bob. Vary Colin, change him with someone else, that's fine. It's not going to affect Alice and Bob. But that idea is entrenched in classical metaphysics. Metaphysics of things with their properties is the idea of classical metaphysics. And quantum mechanics suggests that it is not right. It is wrong. And in ways that undercut our sort of pictures in metaphysics, in philosophy classes. So we aren't getting what we thought we were getting from Impossible Worlds. And indeed, if I'm right, then all conclusions from modal logic and possible world semantics, all intuitions about this can vary and this can vary, and they can vary independently, so you can change this and change that, etc., which feeds into even our intuitions about causality, what causes what. All of those things may be suspect and may need to be revised. The problem is we don't have the tools to do that revision because it's only in the three-particle case that we have a sort of a clear picture of how monogamy is going to work and what that means, and what the shared resources of entanglement can be like. Once you get to more particles, as I said, it's going to get quite tricky. So, to the extent that a modal logic is possible at all, we have no idea how it's going to work. That's my conclusion. And I want to say that, this was entirely what most of my students thought when they were introduced to this idea. It's a nonsense. So that takes me to the end of this, and hopefully this is the last lecture on metaphysics on this topic, because it has been spectacularly unviewed, but it's worth putting it out there for the very few people who are interested in it, and to give an idea of how these things, I think, should go in future discussions. And I think, as it were, for the next 100 years, what should metaphysics be like? Well, I have strong ideas about that, and they're pretty much orthogonal to how it has been taught in the last 20, 30 years at least. So that's that. For the next lecture, I want to try and go on, not to this topic of metaphysics, but to leave it, and instead to do something again on Nietzsche. And that was what we'll come to, hopefully, fairly soon. Okay, bye-bye until then.